Hey, my name's Cole, and in today's video I've decided to showcase how I would image the Andromeda Galaxy. Now, in today's video we're going to be using the ASCAR FRA 400 telescope and my equatorial tracker mount. So the Andromeda Galaxy itself is going to be going directly overhead once all these clouds clear for the entire night. Now, assuming that we don't get any more cloud cover, this will mean we should be able to get about 11 hours of exposure time. Now, what I'm going to try and do is split this up and get a bunch of broadband data, so that'll be our HaRGB channels, and I also want to get some narrowband channel, getting some of that hydrogen alpha data on some of the red nebulas inside of the galaxy itself. So, let's quickly go through the gear which we're going to use tonight in further depth. Okay, so as for the equipment we'll be using tonight, as I said, we're using the ASCAR FRA 400 telescope. This has a focal length of 400mm natively and a f ratio of f5.6. Now tonight what I'm going to be using to image the Andromeda Galaxy is in here a 0.7 times ASCAR reducer, which means we'll be going from a focal length of 400mm down to 280mm, which means our field of view is going to be wider. And also, the rate at which we collect light will be stopping down from f5.6 to f3.9. Now, I also have a 50mm aperture guide scope, which guides at 200mm focal length. So these are pretty close to each other, which means our guiding will be insanely good. We have a guiding camera. We have my DSLR, which is the main imaging camera. This will be collecting the photons from the galaxy and actually making our images for us. Now, this whole rig here is attached to my equatorial tracking mount, which is the HEQ5 Pro. Now, something else to quickly mention as well, we also have here the ASI Air. Now, this is a mini PC and it connects to my phone and it allows me to fully control my entire telescope rig, to the movement of the tracking mount itself, to the shots taken on the DSLR, and the guiding inside our guide camera. Okay guys, next step is complete. We've got everything all turned on and powered, including our ASI Air and our DSLR. So all we really need to do now, I'm probably going to focus my telescope first in the DSLR using a Bahtinov mask, and then I'm going to get into my app on my phone and set up the ASI Air using the polar align tool, get the guidance sorted, and then we might even give the Lemmon Comet, which is somewhere over there, a little go, and then we're going to focus onto our main target being Andromeda, which is somewhere over there through the clouds. Okay, so we now have the Bahtinov mask on the end of the telescope, and if you didn't know what this does, the shapes which are on this mask right here, when you shoot at some stars through your DSLR, the image will create some diffraction spikes on some bright stars, and depending on where those diffraction spikes land, you can tell how focused your telescope rig is. For example, if we now take a quick test shot, as we can see there we have a bright star here, we should now be able to see some diffraction spikes. Okay then, so the polar alignment all went well. We're currently tracking the Andromeda Galaxy. We've taken a bunch of test shots and I'm gonna be shooting at ISO 400 2-minute shots. I could technically do ISO 200 and do 4-minute shots, but because we've got quite scattered clouds everywhere at the moment, if we do 2-minute shots, it will reduce the likelihood that we'll have an error in our data. So I'm going to get as many shots as I can. I'm then going to put the narrowband HA filter in a little bit later into the night, and we'll see how that goes. So hopefully we'll get a bunch of RGB data and hydrogen alpha narrowband data, which we can merge together to make a nice composite image of the Andromeda Galaxy. Let's get to it. Okay, so at the minute this is 2 nights later from what you just saw, and I have here a hydrogen alpha narrowband filter. This one's a 7nm one from Optolong, and I'm going to be putting this into my imaging train to get some hydrogen alpha data in the Andromeda Galaxy, revealing some of those narrowband features such as the nebulas inside of the galaxy itself. Now, in terms of the other night, I only got about 3 hours of data on the Andromeda Galaxy, which isn't the best, but it was very, very scattered cloudy conditions, and we've also had very windy conditions as well, so a lot of the data had streaking stars. It wasn't the greatest, so hopefully tonight's going to be a bit different. We get a lot of data with narrowband, which we can add in to our final image. Now, something else just to quickly mention is one of the main problems with astrophotography, which a lot of us experience and have issues with, is the clouds. Tonight there wasn't meant to be any clouds, but as we can see, the forecast was wrong. Now, we're all polar aligned, we're set up, we're tracking Andromeda, but as we can see, we're completely and utterly limited. Okay, so fast forward 1 hour later, and as we can see, the skies have really started clearing up now. Andromeda will be located just around here. Got the rig just below us right here, and at the minute I'm doing 8-minute shots at ISO 1600 on the Andromeda Galaxy with the hydrogen alpha filter.